Okay, welcome back to another video on the Maths channel. It's your teacher, Miss Lim here, and in this video we're going to be looking at graphing sums and products. So by the end of this lesson, you'll be able to graph the sum, the difference, and the product of two functions given the graphs of f of x and g of x. So let's have a look at the first part of this lesson, graphing the sum. So just a quick recap, let's actually have a look at how to do this without the graphs. So algebraically, I'll do the first one with you, and then you can pause the video and have a go with b. So f of x plus g of x, we're just going to add these two together. I'm going to write this in descending order of power. So x cubed first, plus 2x squared, minus x, minus 1. Right, have a go with b. Okay, so that should be answer 6x squared plus x plus 1. What do you notice about the degree of the new polynomial? And what does this tell us about the graph? So I'm just going to highlight the new polynomials for both of these. And what can we tell about the degree? Well, for a, the degree is 3. And when we compare the two functions, f of x and g of x, the one with the highest power is g of x, with a degree of 3. For question B, the degree of the new polynomial is 2. And when we compare the powers of f of x and g of x, they both have 2. Okay, so the highest power is just 2. So what we can say is that the degree of the new polynomial is the same as the highest power of the two functions, f of x and g of x. And so what does this tell us about the graph? Well, if they are both polynomials, then the graph will be similar to the polynomial with the highest power. Okay? Alright, so here's some keynotes. When adding two functions graphically, we're always looking at the y values. 0 plus y is just y, so it's just going to stay in the same spot. Intersection points double the distance from the x-axis. We're going to look for some easy y values to add. And if both functions are polynomials, it should be in the shape of the function with the highest degree. Just remember, absolute value functions and surds, they're not polynomials, so we can't just use that rule all the time. Alright, so let's have a look at some examples. I'm going to go through question A, then I want you to pause the video and have a go with question B. So for question A, we've got sketch y equals f of x plus g of x. It doesn't matter which one's which. Let's just say f of x is the parabola. So we got like something like x squared. And we're going to add the cubic, the red one. Well, when we do that, we know that our new polynomial will be a cubic. So it's going to look something like this. Okay. Alright, so the first thing I'm going to do after that is I'm going to have a look at for all the zeros. All the y values, all x-intercepts, pretty much. 0 plus 0 is 0, so the new polynomial, or the new function, the sum of these two functions is going to go through that point, minus 1, 0. I've got another 0 here, but 0 plus whatever that is going to be up here somewhere. I don't know what it is, but I do know it's going to be up here. Alright, it seems like there's nothing else, so I'm just going to look for some easy y values to add. So this has a y value of 1, and this has a y value of minus 3. When we add them together, we'll get minus 2. Here we've got 2 and a y value of minus 4. Add them together will be a y value of negative 2. Right. It seems like this one here is about, about 2.4. And this one here looks like it's about negative 2.4. So when we add them together, it looks like they'll add to 0. And now it looks like I can form a graph that will be in the shape of a cubic. Right? We got something like this. Gonna go through here. Gonna come back up. And then it's gonna just reach somewhere way up there. And that should be enough. Alright, so pause the video, have a go with question B. Alright, so let's have a look here. 0, this has a y value of 0. This has a y value of minus 4. 0 plus minus 4 is minus 4. So it's going to go through this point. 0 plus 0 is 0. So I know it's going to go through those points. But before I do that, maybe I should just say we've got the linear one, which is just x, straight line, plus a parabola. So we know that our final answer, our graph, will look something like the one with the highest power, the x squared. So it's going to be a parabola. Alright, so we've identified those points. Let's add some other easy points to add these other easy y values. So this has a y value of 3, and this one has a y value of negative 3, so that when they add together, we'll add to 0. A y value of 4, and a y value of minus 2. So 4 plus minus 2 is just 2. 3 plus minus 1 is also 2. Okay, so it looks like we've got a parabola that's sort of in this shape. Okay, good enough. Alright, I'm going to have a go with question C, and then you're going to have a go with question D. Question C and D, they are not polynomials, right? We've got an absolute value function and we've got a surd on the right. So we can't just assume what shape it will be. So just going to look at my zeros. 0 plus y is y. 0 plus y is y. So it's going to go through those points. 0 plus 6 is 6. Okay. Let's find some easy y values to add. So we've got a 1 and a 5. 1 plus 5 is 6. Also have another 1 and 5. 1 plus 5 is 6. Here's an intercept, and a point of intersection, so I know it's going to double this, so I know it's going to go through about 4. Here's another one. So 2 plus 2 is 4. We're going to go through those. And what are we going to do with this bit here? Let's have a look. So here we've got a y value of about half. So I'm going to add half to this, which is probably about there. Same over here. It's got a y value of half. So I'm going to add half to this, which is about there. So it looks like I'm going to have something like this. As my f of x plus g of x. Alright, pause the video, have a go with question D. Alright, so 0 plus y is y. This one here is going to double. 0 plus y is y, and this one here is going to double. So that's about 1.5. So it's going to be about 3. Let's get rid of that. 0 plus this is this. Here's another intersection point, which is about to, when we double that, it'll be about 4. Around here somewhere. Okay. Here we've got about 1.25 plus 2. That's about 3.25. It's going to be about here. We've got about 1.75 and minus 3. So when we add them, I'll just add 1.75, so 1.75 is going to be down here somewhere. Alright, so it looks like it's going to look something like this. Okay. Alright, so that's it for sketching the sum of two functions. Let's have a look at how to graph the difference of two functions now. Here are my keynotes. When subtracting two functions graphically, be very careful with which one you are subtracting from the other. Intersection points is always equal to 0, because y minus y is equal to 0, or minus y minus y will also equal to 0. So that's nice and simple. Maybe we can start with that. And then look for easy y values to subtract. So let's look at some examples here. Sketch y equals f of x minus g of x. Now here we've got x cubed plus 1, which is the red one. That's f of x. I'm going to minus g of x. So it's always red minus blue. Okay, red minus blue. Now here, if we were to do that, x cubed minus the other one, it's also, our new function will be x cubed something. So it's also going to be a cubic. So just keep that in mind. Intersection point is 0. Seems like that's the only one, so I think that might be the only x-intercept. Anything else? No, I think I will start looking for some easy y values to add. So here we've got a y value of 1, a y value of minus 3. So just be careful, remember it's red minus blue. So 1 minus minus 3 is positive 4. 2 minus minus 4 is positive 6. Okay, now you might be tempted with these 3 points to think, oh, it's going to look something like this. Right, but we should know that it's a cubic. So don't draw that. Because here they approach, there's sort of like a point of inflection here. There's going to be a similar one here. Maybe graph it better. Something like that. Right, and that's f of x minus g of x. Right, pause the video, have a go with question B. Right, so here we've got x minus 1 is f of x, so that's this one. And this one's g of x, so we know it's black minus blue. And intersection point is here, so it's going to be at 0. another intersection point here, so we'll be at 0. And then we can look for some easy y values. So black minus blue. Minus 4 minus 0 is minus 4. Minus 3 minus 3 is minus 6. Minus 2 minus 4 is minus 6. 1 minus 3 is minus 4. Sorry, minus 1 minus 3 is minus 4. Okay, so it looks like I can see a parabola forming. And remember, we're just sketching the general shape of these sums, products, and differences. Doesn't need to be completely accurate. That's good enough. Alright. Question C and D. I'll have a go with this one, and then you can have a go with D. So for question C, f of x is the absolute value of x minus 1, so this one's f of x, so we're doing blue minus black in this case. Okay, so intersection points, nice and easy, zeros. Okay, let's pick some points. So you have 1 minus 5 is minus 4. 0 minus 6 is minus 6. So let's just say that's down here. 1 minus 5 is minus 4. Yeah, I think that's good enough. So it looks like it's going to be something like this. Alright. Alright, pause the video, have a go with D. Alright, question D, this one's f of x, root x. And this one has to be g of x. So we're doing purple minus black. So intersection points, I'm just going to do all of those ones first. That's a 0. That's a 0. That's a 0. Okay, purple minus black. So 0 minus minus 3 is positive 3. We've got about 1.25 minus 2, about negative 0.75. About there-ish. Purple minus black. This minus 0 is this. We can do the same thing over here. This minus 0 is that. And this minus 0 is going to be here. Okay. Let's have a look at this one. We've got about 1.75. And we're going to minus 3. So we're going to add 3 to that. So that'll be 4.75. So it'll probably be about here. Alright, that might be enough. So it seems to me that it's going to look something like this. Something like that. Alright. Now to the final part of this video, graphing the product of two functions. Here's a quick recap. Find f of x times g of x if f of x is equal to 2x squared minus x plus 1 and g of x is equal to x cubed minus 2. I'll do A. You can pause the video and have a go with B. So f of x times g of x we've got 2x to the power of 5 minus 4x squared minus x power 4 plus 2x plus x cubed minus 2. Let me just put that in descending order. Alright, pause the video, have a go with B. Alright, so here's the answer. 8x to the power 4 plus 4x cubed plus 2x squared plus x. So what do you notice about the degree of the new polynomial? And what does this tell us about the graph? So again, I'll highlight. Here's my new polynomial for A, and here's my new one for B. The degree for A is 5. Well, how do we get that? Well, 2 plus 3, that's 5. The degree of the new polynomial for B is 4. How did we get that? Well, 2 plus 2 is 4. So it seems like the degree of a new polynomial is the sum of the degrees of the polynomials that were multiplied. And again, this will tell us the shape to expect, right? If it's an even power, then we'll know it's like a parabola or a bumpy parabola. If it's an odd power, we know it's a cubic or a bumpy cubic, something like that. So let's just write that in. The degree of the new polynomial is the sum of the degrees of the polynomials that were multiplied. So this tells us the shape to expect. Again, this only works when they are both polynomials. So keynotes. When multiplying two functions graphically, remember 0 times y is 0. Look for easy y values to multiply. If both functions are polynomials, then the shape of the new polynomial can be determined by multiplying the highest powers of x. Well, in this case, we're going to be adding the powers for both functions. And then just remember, a negative times negative is positive. Negative times positive is negative. So let's have a look at these examples here. In question A, we've got g of x is x squared plus 2x plus 4. F of x is x minus 2. So when we add the powers, because when we multiply the terms, x squared times x will give us x cubed. So technically we just add the powers x cubed. So we know that it's going to be in the shape of a cubic. Right? Alright, so 0 times whatever this is will be 0. So I know it's going to go through that point. Let's look for some other easy values to multiply. 4 times minus 2 is minus 8. Let's go with this one. Minus 1 times about 7.5 will be about minus 7.5. Here we've got 3 times minus 3 is minus 9. Okay, so we know that it's going to look like this because we know it's a cubic. And it's going to go through that point there. Alright. Why don't you pause the video and have a go with question B. Alright, so question B, we know that we've got x squared, we've got a cubic, and we've got a linear. So it's going to give us x cubed. So it's going to be a cubic as well. Right, 0 times 1 is 0. 0 times 1 is 0. It's going to go through those 2 points. Alright, let's look for some easy values to multiply. 1 times 2 is 2. let's see, minus 1 times 4 is minus 4. We've got 3 times 4, that's 12. Alright, and then here, looks like we've got something positive times something positive is positive. Okay, they're both less than 1, so it's going to be less than 1. Right, two numbers smaller and 1 multiplied together will give us an even smaller number. So it looks like it's going to be like this. Alright, now you might have been tempted to have gone down here, right, and then come down, but just remember, positive times positive is still positive. It doesn't become negative, so it won't go below the x-axis between 1 and 2. Okay, so just be careful. Alright, last two questions. So 0 times minus 2 is 0. 0 times 2 is 0. So there's going to be 2 x-intercepts. Can you see how all of this bit here is negative and all of this bit up to there is positive? Positive times negative will be negative. So it's going to go below the x-axis. And then from there on, they are both positive. So it's going to go above the x-axis to the right of 2. Alright, so let's just find some easy y values to multiply. 1 times minus 3 is minus 3. It's going to go through that point. We've got minus 2 times about 1.4. So that's about negative 2.8. That's about there. Negative 1 times this is negative about 1.75. It's about there. Alright, let's see. 1 times this is that. 2 times about 2.5, which is about 5. It's going to be around there. Okay, so it looks like we've got this shape here. Right, pause the video, have a go with D. Alright, so for D, I know there's going to be 2 x-intercepts here and here. Alright, here we've got a point of intersection where they're both negative. So minus 3 times minus 3, that's positive 9, so that's really high up. Minus 2 times minus 2 is positive 4. Minus 1 times minus 1 is 1. Alright. Oh, maybe I should have also noticed that this is x, this one here, and the one looks like it's a cubic. So it's going to be x power 4, so I know it's probably going to be a bumpy parabola. Alright. Now, to the right, we'll see between here and here, between these 2 points, the black one's negative and the red one's positive. So negative times positive will be negative. It's going to come down into the below the x-axis. And it's going to come down somewhere around here. But to the right of x equals 1, they're both positives. It's going to be going up. It's going to be going up like that. Alright. So looks like it's going to look something like that. That's my bumpy parabola. Alright, so I hope you found this video helpful. This was a video on how to graph sums, differences, and products of two functions when f of x and g of x are both given graphically. Have a great day, and I'll see you guys in the next video. See you.